I'm going to talk about moral alignment, which I think is a core part of what cooperation should be and how we get there. Obviously, it's only one way of looking at it. Given the talks so far already, there are maybe like more normative solutions we could work on, but this is individualistic, looking at an agent, how could they be made slightly more moral? I'm not representing any institution. I'm literally unaffiliated for another week, but I was at UCL until very recently. So the way I define morality is considering the impact of an agent's choice on others in a multi-agent interaction. So it's very specific to this multi-agent setting. I'm not going to define the agent. I think everyone's on the same page. But it's not any like free will, wacky directions. It's literally an agent that's given a goal and choosing actions towards that goal. Everyone knows social dilemma games. I find even just the core 2x2 games still really valuable. I know there's people in the room who differ in that opinion. But I think the abstract like two-action distinction and the self versus opponent mapping is really useful. So that's the environment in which we've done the experiments that I'm going to talk about. And I think as a result, this like underlying general structure of decision-making situations applies to a lot of everyday situations, although there's a bunch of follow-up work I would love to do or work with other people on to like prove that generalization. OK, so traditionally, if you do RL in these games, you know, your opponent is part of the environment. You get this defecting equilibrium with tabular agents, LLM agents, et cetera. But humans manage to cooperate in these environments. Why is that? I argue that we have some bias for, or like a moral prior, which plays a key role for us resolving social dilemma-like situations. That's the motivation for building this into agents. So I'm looking at like the alignment problem as you've got task-specific goals, but also moral values or institutional norms and laws that should also feature in your decision-making. And they're kind of drawn here as orthogonal, but they don't have to be. But they might not be exactly the same thing. So the way that I've addressed this is instead of training with the reward in the game, train with an intrinsic reward to the agent, which is also inspired by work of people in the room. So hopefully will be familiar to a lot of you. I just want to fit that within a broader framing of approaches to making an agent behave slightly more prosocially. Somebody in a talk earlier did this from like top to bottom. This is a left to right, similar spirit. But you could be very top down and like prescribe rules, Asimov's laws or model specs, very explicit principles that an agent wants to follow that I consider to be top down and not very generalizable and maybe contradictory within the rules. The other extreme would be fully bottom up, where the agent or the algorithm would infer preferences that are implicit in the data. So RLHF is an example of that. I mean by that pure RLHF, where the nothing is specified to the humans. Humans just give their feedback, which is not what happens in practice these days, but theoretically. And then inverse RL from demonstrations would be another example. So this sits somewhere in between those two. I see the intrinsic rewards approach similar to like constitutional AI as being a hybrid, where you've got some explicit principle that's defining the learning signal, and then the agent learns from that. And the benefit is you can get better generalization, but also more transparency and understanding of where the principles came from. Also, for the intrinsic rewards part, which I'll talk about today, there's no need for human data, and you can train with this self-play paradigm, which is really powerful. The way that we frame this is by combining RL with moral philosophy. This is a massive simplification of moral philosophy to those in the room that are philosophers, but we try. So we kind of take the definitions of norms and preferences from core philosophical frameworks, put them into reward functions, and then get the agent to learn according to them. Here's an example of how you could do that. So if you're following something like Bentham, you might define a utilitarian agent. That's definitely been done in a lot of other work, which is in this game would just be maximizing the sum of the payoffs. If you're a Kant-inspired agent, you might be deontological, for example, following conditional cooperation as a norm. So we get punished if you defect against the cooperator. Or you might try and like put Aristotle into this, which is much harder because it's more complex. But we did that with, you might care about equality, or you might care about kindness. So you might have consequentialist or norm-based principles that you care about. In one study, we also did like an inverse of that to be antisocial agents too, to make it more interesting. So this is an example, but the framework is much broader. You could basically model any principle with this. The three studies that I just wanted to highlight, I'm not going to go into too much detail, but we do this in pairs of agents that are pure RL, learning against a consistent opponent, and then you can evaluate what they do during learning, outcomes at the end. We do this in populations with partner selection. This is following on from another piece of work in my lab. And there you can get really interesting sort of like reputation mechanisms because you want a signal being cooperative, but once somebody selects you, you might defect. So these two studies are PRL. And then finally, applying this to LLM agents opens up the avenues for so many more things. So by describing the game in text form and giving specific tokens to mean actions, you can train on one game, evaluate generalization to other games. We specifically fine-tune a small open source model with intrinsic rewards within this framework. But you can also do this for large models, of course. And what we measured there was, learning and unlearning. You can also evaluate generalization, which I think is really interesting. Really high-level results. In the dyadic setting, broadly they work. These model rewards work. But there's some, you need tons of exploration if you're doing tabular learning, which maybe everyone would know already in this room, but we didn't start out with. And there might be some exploitation. This is specifically for the equality agent, learns to be exploitative before convergence, which we didn't expect. In the population case, we saw that you can actually, by having a heterogeneous population of agents, all with different moral preferences, you might steer a selfish agent towards learning more cooperative policies. Only in 1 out of the 9 populations that we studied. So it was kind of unexpected and gives us hope to if we end up in a world where we can't control all the agents, we can still steer them in this way. We also saw some self-sabotage of some norm-based agents selecting defectors so that they never get punished. Kind of makes sense in hindsight, but didn't then. And then on the LLM side, the one thing I find most interesting is you train on one game, and then you can just swap out the payoffs at test time, and the agent has still been fine-tuned on the same game. And we evaluated to what extent policies generalized from one to the other. We saw that norm-based policies generalize much better than consequentialist ones in this setting, but I think there's more to do. I think I've said all this, so it's a summary. More of what should be next. These are just some things based on people I know are in the room that I think are super interesting. Maybe we could talk about if anybody's interested in any of these ideas. So I've thought about generalization more broadly, which is where this emergent misalignment piece came in. I did a bit of follow-up work on that that I spoke to somebody about as well the other day. I'm thinking about benchmarking this in more real-world situations. Evaluating moral competence, eventually moving on to human influence and how might human and AI interact in this sort of environment, simulating human behavior and generative ABMs and things like that. I find that all interesting. I would love to be thinking more about, so please help if anyone's working on this, how stuff like curriculum design and open-endedness might fit into this training generalization for morality. If there's a neuroscience-inspired architectural solution that it could enable moral reasoning and cognition. This is really wacky open question space. Maybe theoretical analysis on, people working on debate for very obvious yes-no situations. Could you work on debate for domains where there isn't a yes-no answer? More on specifying rewards in a multi-objective sense, or reward modeling, but not with just human feedback, but slightly more conceptual. Thanks for listening.